Today we're going to be talking about segments and distance. Guys online, make sure you're copying down the notes and then submitting them, taking them a picture and sending them to me on Canvas. Okay, so we have a line segment. That is part of a line consisting of two endpoints and all the points between them. Okay, so there's your definition of a line segment. We talked a little bit about that on Friday. So the line segment's a part of a line consisting of two endpoints and all the points in between them. We talked about a line at least had to have 2 points on it. It could have more points, but it had to have at least 2 points for it to be a line. A line segment does stop at the 2 endpoints, but it can have other points on it. It just has to stop at 2 points. Okay, and so here it says the measure of the length of a segment. You can use a number line to find the distance between 2 points, or you can use a formula. So the formula is the absolute value of A minus B. So these lines right here are your absolute value lines. They're not a 1. That is your absolute value. Okay, so if you choose to use the formula, you can. For this one, it says find the distance between -2 and 6 on a number line. If you go from -2 to +6 on your number line, you're going how many units? You're going to 8 units. From -2 to 0, that's 2 of them. Plus 6 is going to give you that 8 units. So to use the formula, the distance for a number line, the absolute value of A minus B, and we're going to substitute in the -2 minus, because that's part of my equation, and then I have a 6. So then you've got -2 minus 6, you get -8. And the absolute value of -8 is +8, because every time it comes out of the absolute value, it's positive. So we went 8 units from -2 to +6. It was 8 units. That's the distance. Okay, on this one down here, you go from, you find PQ, so from P to Q, from here to here. Okay, so P is located at -3.5, and Q is located at -2. So we're going to put that in our formula for the distance of the absolute value of -3.5. So -3.5 minus, because that's part of my equation, subtraction, and -2. Put that in your calculator. What's -3.5? Minus -2. If you need to go grab a calculator, you can. Does anybody know what it is? Go ahead.
-5.5.
No, but I'll give you guys some time to go get it get a calculator, exchange it for your ID or your cell phone. Can anybody else tell me what -3.5? Go ahead. Okay, so it's going to be 1.5. You can do your keep, change rule, or just put it in your calculator. You should get -1.5. Okay, and then the absolute value of -1.5 is just a positive. So the distance from there to there is just 1.5 units. So 1.5 units from P to Q. Okay, so again, you had -3.5 minus a -2, which becomes -1.5. As you can see, they're 1.5 distance away from each other, or units away from each other. And that's where you get that. The absolute value of -1.5 is +1.5. Okay, on this one, Q is equal to -2. R is at, so we're looking from Q to R this time. Q is at -2. R is at 2.5. And then we're going to find the distance, the absolute value of -2 minus 2.5. Okay, and so that's going to be the distance of -2 minus 2.5. Cooper is what?
0.5?
No. Go ahead. Okay, so -4.5. And you guys can put that in your calculator if you wanted to check it. -2 minus 2.5 is -4.5. The absolute value of -4.5 is always going to be positive, so that's going to be positive 4.5. Okay, so it's 4.5 units from Q to R. And then the last one we're going to look at is from P to R. So from P to R, we're looking from P all the way to R right here. And so when we go from, here's my P, which is located at -3.5, and my R is located at 2.5. The distance formula is the absolute value of the first one minus the second one. And so you can put that in your calculator there, and -3.5 minus 2.5, Kendrick, is what? Okay, that gives me -6. Put it in the absolute value, and the absolute value of -6 is 6. And so they are 6 units away from each other, which makes sense from 2.5 all the way over here to -3.5. Okay, so 6 units away from each other. Then again, makes sense because this right here and this right here added together gives you the whole length, which is PR. Okay, turn to the second page. The formula for using distance on a number line, that is the square root. Okay, and you're going to have 2 points. You're going to have a point that has an X and Y value, and then another point that has an X and Y value, and I'll show you how to use that. But the square root of the second X minus the first X squared plus the second Y minus the first Y squared. Okay, so this is on a grid. And you're seeing that the square root, the second X minus the first X, we're squaring that, make sure it's in parentheses, plus the second Y minus the first Y in parentheses squared, all under the square root. This is when it's on a grid. Okay, a grid looks like when you have your X and your Y and how to find the distance from one point to another. This one over here, when we use this formula, this was on a number line. Okay, so it's just different. All right, so if we're looking at a grid and we have one point at 2, -1, that's going to be our first X and our first Y, so label that. This is going to be our second X and our second Y, and label that. So it's not really hard, you just have to make sure you label them. Then you just stick these numbers or substitute these numbers into your equation. So your distance between this point, or to this point, from this point to this point, the distance from one to the other, is the square root. And so I'm looking at my equation here, it says to put the second X first. So that's going to be a -2. My equation has a subtraction sign, so I put minus. And then I have my first X, which is 2. Then I have a plus in between those. My second Y, which is -1, minus, because that's part of my equation, so minus. My first Y, which is right here at a -1 squared. Okay. Now you guys can put all that in your calculator if you want to. Parentheses, and you can even put it under the square root. For some calculators it doesn't work as perfect, so let's just do everything underneath here. So in your calculator, put parentheses, -2 minus 2, close parentheses, squared. Does everybody understand where that's at? Let's go ahead and make sure we have that. If you don't have a calculator, you might want to grab one. Okay, so I'm putting parentheses and then negatives down here, -2 minus is right here, and then 2, close parentheses, my squared is right here. It's this part right here. Here's my 7, just looking up right there, that's my squared. And then I put plus, parentheses, -1. Again, here's my negative down here, -1 minus a -1, close parentheses, and then squared again. So here's my squared. Okay, I'm gonna press enter. Okay, what'd y'all get? Okay, so remember that's all underneath the square root. Okay, so don't forget that that square root's still there. So you can put all that in your calculator, and sometimes it'll allow you to go ahead and put that. Some calculators may do a little bit different, so I go ahead and do this. But the square root of 16, what's the same number times the same number that will give you 16? Okay, so the distance from this point to this point is 4 units. They are 4 units away from each other. And then again, you can, if you didn't know what the square root of 16 or whatever, you can put second, which is this blue button, and x squared, which is square root, and then you can put 16 in. Okay, so you can get that. Okay, so I just push second, x squared will give you the square root, and then put 16, enter. Okay, we're going to go ahead and do this one as well. So listing this one as your x1, y1, because your first points. This is your x2, y2. This is your second points. Looking at that equation again, the square root. And looking at it up here. I got my second x minus my first x. Don't forget that you have that squared, plus my second y, minus, because that's part of my equation, my first y, which is a -2. Don't forget to square that. Okay, does everything look right? Because sometimes I can make a mistake too, so y'all have to let me know if something doesn't look right. Okay, so everything looks good to me. So I'm going to put all that in my calculator, use the parentheses, -2 minus 5, close parentheses squared, and so forth. Okay, so the distance is equal to the square root of 50. Is that what y'all got? Okay, so this one's going to be done a little bit differently. We don't want the decimal because when you guys, this year, you're going to be finding the simplified radical. Okay, so the square root is your radical. The simplified radical is when you do the prime number tree kind of sort of thing. What will go into 50? What times what? What times what will give me 50? Go ahead. Okay, so 10 times 5. You could even say 2 times 25 if you wanted to. Whatever you want to start with. Okay, and then I'm going to go down. 5 is prime, correct? Only 1 in itself will go into it. Okay, is 10 prime? No. So what times what will give you 10? Go ahead. Okay, so 5 and 2. Okay, and so I'm just looking at my prime numbers. I'm going to mark out just so I can make sure that you guys are just looking at those prime numbers, and I make it real clear for you. So I go ahead and I underline them. Now, these are still underneath the square root here. I'm going to rewrite that as the distance is equal to the square root of 2 times 5 times 5. Okay, if I have doubles, that means, what's 5 times 5? 25. What's the square root of 25? 5. So if I have doubles, it's like I'm taking just one of them because the square root of 25 is 5. I don't have two of the 2's. I only have one of them. So that stays in my radical here. So that's fully simplified in radical form where you have the square root. We're going to use this year in geometry. So maybe it's the first time that some of you have seen it, but we will use that.
That's called a simplified radical, you said?
Simplified radical, yes. If it will simplify, if this is not a prime number here and it will simplify, then we will simplify it. Okay, yes. Did you have a question? Go ahead.
So I know this isn't the correct way to write it, but would it still give you the same number if you put 5 squared times 2 inside the radical and so on?
You're talking about 5 times the square root of 2?
I meant 5 squared times 2 inside the radical, would that be?
That would be incorrect. Because to simplify it, it has to go on the outside. If you're leaving it the inside, it's the same thing as the square root of 50, and that's not simplified. Okay. All right, so this one, here's how you're going to see distance. It's going to say find AB. And some of you will be like, what am I finding? What do you think you're finding? The distance. You're finding the distance from A to B. Okay, so we can draw a line right there if you want to. We're finding the distance from A to B. How far is it from A to B? So you will see, and some of your tests may say find AB. It's looking at distance, and you may want to write that in. It's looking at distance. Okay, where is A located at? A is located where?
2, 3.
Okay, so 2, negative 3. And B is located where? 4, comma, positive 5, right? 1, 2, 3, 4, 5. Does that look right to y'all? Okay, so there's my points. What am I going to put underneath them? X1 and Y1, because that's my first points. And then I've got X2, Y2. Perfect, good job. And then you just put it in your formula. So the distance is the square root. So when we got a grid, this is the one we use. Our second axis minus our first x squared plus our second y minus our first y, which is a negative 3. And then just put that in your calculator. Okay, so I got parentheses, 4 minus 2. Plus parentheses, 5 minus negative 3. Don't forget about your squared on the outside of those. What y'all get?
64.
Got 60 what?
65.
What y'all get?
68.
Okay, I got 68. All right, so then, so is 68 a prime number? That means 1 in itself will only go into it. Do y'all know another number that will go into 68? What will go into 68? Well, it's an even number, so we know
2 and
2 will go into it. So 2 and what? Divide that by 2, and what do you get? 34. Okay, so yes, 2 times 34. 2 is prime, but is 34 prime?
you gotta break it
Okay, so what times what will give me 34?
17 times 2.
Okay, so 17 times 2. Now remember, I'm only looking at the prime numbers. That's why I go ahead and mark these out. Go ahead and mark this one out and this one. And then I rewrite it so that you can completely understand it. So that's the square root of 2 times 2 times 17. 2 times 2 is what? 4. It's a double. That's how I kind of look at it too. If you got 2 of them, then you take one of them out because the square root of 4 is 2. So the distance is equal to what? 2 square root of what?
17.
Yeah, you only have a single of a 17, so it stays on the inside. Doubles, if you have a double, goes on the outside. Does anybody have any questions on that so far? Okay, so that's your distance.
What if you have 2 doubles?
if you have two doubles, let's say you had two twos, and then you had two threes in here. So if you had two threes over here, one of your threes will come out, one of your twos will come out, and then you just multiply them on the outside. So it'd be 2 times 3 would be 6. Okay. But we'll get into that form. Okay, so this was just a question that we just recently looked at, looking at the example 2 on our first page. So it says examine the measurements of PQ, QR, and PR in example 2. Notice that this is what the units we got was equal to 6. And just I'll look at it here. This was 1.5 units away from each other. This right here, the distance is 4.5 here. Add them two together and you get what? The whole distance, right? From P to R here. Okay, so that's what it's saying. It's just saying that if you add these two together, you're going to get the full distance. So, PQ plus QR is equal to PR. Now, this should be pretty easy for you guys to say. And here's an example. Looking at this, this is called your segment addition postulate. It's adding this plus this is equal to the total. And we'll go over it in example 6. Okay, in example 6, you said if B is between A and C, so draw a line. B is somewhere in the middle. You can just put it wherever you want to in the middle. It doesn't say it's directly in the middle, it just says it's between those two, right? Okay, so it tells me that it's between A and C, and then AB, from A to B here, is 4 units. And then from B to C is 5. Then the total from A to C is equal to what? 9. Okay, so from A to C is equal to 9 units. It should be that easy. This plus this equals the total, right? 4 plus 5 equals 9. That seems really easy, right? Okay, so we're going to get into some expressions. All right, on example 7. So we've got, we're going to draw this out. It says that if AB is X and BC is X plus 6, they should have told you that right here, they should tell you that B is in the middle. But they didn't, but that's okay. I'm telling you B is in the middle somewhere. Or in between those two. B is in between those two. So if A to B is X, and from B to C is X plus 6, and they're giving me the total here, what are they telling me A to C is?
24.
24. How am I going to do that one? Kendrick, how are we going to do that one? Are you writing this down? You're writing this down, right? Okay. Everybody make sure that you're writing down the notes. Logan, what do you think? How do we do this? Who can tell me? Fabian, what do we do? Go ahead. What do we do?
You subtract 6 from 24 and then put
Yes, eventually. How do I set up the equation first? How do I set up the equation first? Go ahead.
Combine the x's.
Okay.
6.
Okay. Perfect. I'm going to combine them. I'm going to add them. So I'm going to show you all of it together. And you guys are going to get to think for a second, why am I adding those two together to make them equal to the total? Why would I do that? How does that make sense? How does that make sense with this one? Y'all said the total right here was 9, right?
Because AB equals X and BC equals X plus 6. So you just
Make it equal to that total, right? This part plus this part right here, this plus this, just like this plus this when we use numbers, is equal to the total. Same thing here. This plus this is equal to the total. So that's all you're doing that. So if you can get that concept, like this plus this is equal to the total, you're going to be okay. All right, so we have an understood 1 in front of these two. Okay, so that's going to be x, 1x plus 1x, which is 2x. Okay, Paola, can you tell me what happens next? Okay, subtract the 6 from both sides. And tell me what's next.
You,
So what is
divide,
this?
you divide by 2.
Okay, so I'm going to subtract this. What is 24 minus 6?
18.
18. And then what's next, Hayden?
You divide 2 by 18 and then x equals 9.
Okay, opposite of multiplication is division, so x is equal to 9. What is it asking for, though? Okay, it's asking for A to B, which we should know that, right? What is that? Okay, so it's 9 units. That means that units behind it can be centimeters, it can be inches. We don't know because they don't tell us exactly here. But if it was inches, it would be 9 inches from here to here. This part right here is going to be from B to C, which is going to be what, Noah? Yeah, this one, from B to C, what is that? Yes, why would it be 9 here?
It's x.
Well, no, why would, this is 9, X is 9, but what's B to C?
15.
Yep, 15 units. Okay, so then from B to C, because you're going to substitute this 9 in for X, and 9 plus 6 is 15. So from here to here, because you're just substituting that number in. It doesn't make sense. 15 plus 9 total is 24. Yes. Okay, we're going to draw that out. This time they say that L is between, so L is somewhere in the middle between N and L. Now, obviously, I'm not drawing this perfect, because if it was perfect, this side would be a little bit longer, right? But I'm doing the math correctly, so the picture is not exact. But anyways, L is between N and L. Okay, and then it tells me that NL is 6x minus 5, and LM is 2x plus 3, and then from N to M is 30. All right, Tanner, how would we set this equation up?
8x equals 30.
Madison, how would we set this equation up? Yep, how do we do this? How do we set up the equation? Raise your hand if you know how to set up the equation. Okay, so let me help y'all back out again real quick. How did we set up this equation? N4 plus 5 equal to 9, right? So what are we doing with these two? We're doing what? Adding them together, make them equal to the total. So same thing here. When you're given an X, it's nothing different, okay? Even though you have an X in there, I know. It changes a little bit, but at the same time, you're still doing the same process. All right, Austin, what do we do?
You put the 6x minus 5 and 2x plus 3 together equals 30.
Okay, so we're adding the two. This plus this gives you the total, which makes sense. Just like this plus this gave you the total. This is 4 units. Let's say this is 4 inches. This is 5 inches, equals a total of 9 inches. Okay, it's the same thing. Even when you have X, you're adding the two together, make them equal to the total. Okay, combine my X's here, Madison. What's 6x plus 2x? Okay, so we got 8x. Negative 5 plus 3 is what, Artem? Negative 5 plus 3? Okay, so minus 2. Good job. And Paola, can you tell me what we're going to do next? Okay, so opposite of subtraction is addition, so we're going to add 2 to both sides. That gives me 32 on one side. And the last thing that we're going to do there is going to be what? Salas. Okay, opposite of multiplication is division, so we're going to divide, and so my answer is 4. Is that all we're looking for?
No.
So make sure you go back up and look and see what you're looking for. We're looking from L to M, so from L to M. Y'all go ahead and figure that out, and I'll call on somebody when they have that figured out.
multiply the 6 by the x.
Okay, if you're looking for n to L, if you're looking for this distance right here, then yes, you would put the 4n for the x and multiply and then subtract 5. But you're not looking for this distance right here, right? You're not looking for this distance, right? You're looking for this one, right? Because that's what it's looking from L to N. You got it?
Answer.
What'd you get?
11 units.
Okay, so let's check. Do y'all agree with 11?
Yeah.
All right, I agree too. And let's just see. So we've got 2 times 4, which is 8, plus 3, which is 11. Perfect. Okay, good job. Let's keep. That's it for those notes. Okay, so what I'm going to do, you guys online, make sure you do your work. Make sure you show your work, all of your work, and make your work nice and neat. Okay, we're going to talk about section 2.4, which is your distance and midpoint, in just a little bit. I'm gonna go. I saw that.